So let us verify this Cayley-Hamilton theorem for the matrix, which is A, and also find the inverse of this matrix. Okay, so the characteristic equation is A minus lambda I, which is equal to 1 minus lambda and 2, 2 and 1 minus 1 and lambda. Okay, so which is equal to 0. Okay, so this implies, after simplifying, we get this as lambda squared minus 5, which is equal to 0. Okay,
Yes, sir.
now after that, so a square will be, that is 1, 2, 2 minus 1 and 1, 2, 2 minus 1. Okay, let us multiply this. So you get this. Okay, so a square minus 5i, which is 5005 minus 5005, which is equal to 0. So we have verified, right, and
Yes, sir.
the Cayley-Hamilton theorem. Now, therefore, A satisfies the characteristic equation. Okay. Okay. Now let us find the A inverse. Pre multiplication, by A inverse yields, that is A minus 5 A inverse, which is equal to 0. So A inverse is 1 by 5 A, which is equal to 1 by 5, 2 by 5, and 2 by 5 minus 1 by. So hence we found what is A inverse also. Okay, let us find A inverse for the matrix. Okay, using Cayley-Hamilton theorem. Okay, so the characteristic equation is given by, that is A minus lambda I, which is equal to 0. Okay, so which is A, which is 1, 2, 3, 2, 4, 5, and 3, 5, 6, minus lambda I 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, which is equal to 0. This implies as, yeah, tell me, 1 minus lambda, right?
1. Yes.
Then
2,
2, 3,
3,
again
2,
2,
4 minus
4 minus lambda, that's great.
5,
5,
3,
3,
5,
5, right? Yeah.
6
and
minus lambda.
6 minus lambda. Yeah. Okay. So let us continue solving this. Now, it is 1 minus lambda. Now that will be multiplied into 4 minus lambda and 6 minus lambda minus 25. Okay. And minus 2 into 2 into 6 minus lambda minus 15 and plus 3, 0 minus 3, 4 minus lambda, right? Which is equal to 0. Okay. Now let us further simplify it. So we have taken row wise. Okay. Yeah. So what do we get? Minus lambda cube plus 11 lambda square plus 4 lambda minus 1 is equal to 0. So this implies lambda cube minus 11 lambda square minus 4 lambda plus 1 is equal to, I will change the sign. Okay. Okay. Now, hence we got this equation, characteristic equation, and by Cayley-Hamilton theorem, we have that every square matrix satisfies its own characteristic equation. So hence A must satisfy its equation. So that would be A cube minus 11A square minus 4A plus 1, which is equal to 0. Okay. So first let us calculate what is A square now. So which is A multiplied into A. So that is 1, 2, 3, 2, 4, 5, 3, 5, 6, 2, 3, 2, 4, 5, 3, 5, 6. Now let us multiply. So we get this is 1, 2 into 2, which is 4, 3 into 3, which is 9, 1, 4, 9. Next 2 plus 8 plus 15, then 3 plus 10 plus 18, right? And 2 plus 8 plus 15, right? Again 4 plus 16 plus 25, and 6 plus 20 plus 30, and 3 plus 10 plus 18 and 6 plus 20 plus 30. Okay, and also the final one, that is 25 and 36, right? So after multiplying this, and the final matrix of A square, which is 14, 25, 31, 25, 45, and 56. 31, 56, and 70. I got this. Okay. So multiplying the equation which is 1, right? We'll keep this as equation 1, okay? Both sides by A inverse, okay? We'll multiply. So okay, when we multiply it, so with A inverse, okay, multiplying both sides. So we get as A square minus 11A minus 4A yeah,
A cube.
okay. So again we want A inverse, so that is A inverse is equal to minus A square and plus 11A plus 4I. Okay. So let us substitute A square here. A square we already found, which is 14, 25, 31, 55, 45, and 56, right? And
Yes.
31, 56, and so on.
7.
Yeah. And plus 11 into, so A is given, so let us multiply that also. Okay, so I'll multiply with 11. So what we get is 11, 22, 33, 22, 44, 55, and 33, 55, and 66, plus 4i. 4i is 400, 040, and 004. Okay, get this. Okay. Okay. So this will get as 11, sorry, 1, and minus 3, 2, and minus 3, and 3, minus 1, 2, minus 1, and 0. Yes. So we got what is A plus here. Okay, let us find A inverse for the matrix A using CAYLEY-Hamilton. Okay, the characteristic equation is given by A minus lambda I, which is 0. So that would be okay, A, which is 2 minus 1, 1, and minus 1, 2, minus 1, and 1 minus 1, 2, right? So minus lambda 0, 0, 0, 1, 0, 0, 0, 1, right? Hmm. So which is equal to 0. Hmm. Now this implies that 2 minus lambda minus 1, 1, minus 1, 2 minus lambda,
2
and
1.
minus 1, right?
Yes, sir.
1 minus 1,
2 minus lambda.
2 minus lambda. Yes. Is equal to 0. Hmm. Okay. So let us solve. On solving, you get as 2 minus lambda. Okay.
Yes, sir.
So that will be 2 minus lambda, and 2 minus lambda will get as 2 minus lambda whole square. Okay. Minus 1 plus 1 and minus 2 plus lambda, okay, plus 1. And plus 1 multiplied into 1 minus 2 plus lambda, right? So which is equal to 0. After simplifying, we get that as lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0 with this. Okay. So which
Yes, sir.
is a characteristic equation, right? And we need to show that A satisfies this. So that's what to show, right? That is
Yes.
A cube minus 6 B square plus 9A minus 4, which is equal to 0. 4I is equal to 0. Okay.
Yes, sir.
Hmm. So we'll verify that. So A square, which is A into A. So that will be 2 minus 1, 1, minus 1, 2 minus 1, and 1 minus 1 and 2, right? Okay.
Yes, sir.
So let's multiply this. So it's 4 plus 1 plus 1, and minus 2 minus 2 minus 1, and 2 plus 1 plus 2, right? And this is minus 2 and minus 1, 1 plus 4 plus 1. Okay. Okay. So you get this. After simplifying it, so you get 4 plus 1 plus 1, which is 6. And this is minus 6, minus 5. Okay. And this is
Yes,
6 again. And this is minus 5. And this is 6. This is minus 5. Okay. And 5.
-5 ಆದ್ಮೇಲೆ 6 5 ಆಗತ್ತೆ. 2 + 1 + 2.
So this is 5. Huh?
Yes,
And,
sir.
minus 5. And then 6.
6.
Now let us find what is AQ. And AQ will be A square to A, which is A square, we got that as 6 minus 5, 5, and minus 5, 6, minus 5, and 5 minus 5, and 6, right? So this is multiplied into 2 minus 1, 1, and minus 1, 2, minus 1, 1 minus 1, 2, right? So let's, after multiplying it, again, get 22 minus 21, and 21 again, so minus 21, 22, minus 21, minus 21, and 22. Okay, so finally we'll substitute in A cube minus 6A square plus 9A minus 4I. Okay, let us substitute here.
Yes, sir.
So we got what is A cube, that is substituted. Minus 22, minus 21, 21, minus 21, 22, minus 21, 21, minus 21, and 5, minus 6 multiplied into A square, which is 6, minus 5, 5, and minus 5, 6, minus 5, 5, minus 5, and 6. Right?
Yes, sir.
So plus 9 into A, which is 2 minus 1, 1, and minus 1, 2 minus 1, and 1 minus 1, 2. Okay, so minus 4, multiply that also. So it will be 4, 0, 0, 0, 4, 0, 0, 0, 4. Okay,
Yes, sir.
so which will be equal to 0, right? After simplifying. Okay. Hence, CAYLEY-Hamilton theorem is verified. Okay. Now
Yes, sir.
let us find the inverse. Okay. Okay, so after multiplying A inverse on both the sides, we get that as A square minus 6A plus 9I,
Yes,
okay, minus 4A inverse, right? Which is equal to 0, or A inverse will be 1 by 4, okay, multiplied into A square minus 6A 6A plus 9I. Okay, now let us find A inverse. So 1 by 4, brackets, curly brackets, A square, which we got as 6 minus 5, right? 6
yes, sir.
minus 5, 5,
5 minus 5,
minus 5, yeah,
6
yeah,
minus 5,
yeah.
5
Hmm.
minus 5, 6.
Yeah. So we'll take 6 inside. Okay, so that will be minus 12, right? 6, 6, and 6 minus 12, and then 6, 6, and 6, minus 12, right? And the last term, which is 900, 090, and 009, right? Okay.
Yes.
Yes. So after simplifying the inner brackets, right, we get that as 3, 1, minus 1, and 1, 3, 1, okay, and minus 1, 1, 3. And further simplifying it, get 3 by 4, 1 by 4, and minus 1 by 4, and 1 by 4, and 3 by 4, and 1 by 4. And the last one, minus 1 by 4, 1 by 4, and 3 by 4, right? So this will be your A inverse. Okay. So
Yes.
hence we have also verified the Cayley-Hamilton theorem, as well as we also found what is A inverse also, right? Yeah.